This call is now being recorded.
Okay.
Mr. Chan, wouldn't your stylus for your iPad work elsewhere?
No, it doesn't because it's like Samsung like specific.
Oh.
Yeah. It's not like one of those stylus that's like universal, you know? All right, good morning, guys. So thank you again for coming to office hours. We are beginning a new week. So today's May 18th. We are continuing our discussion on circles. So just to recap a little bit about last week, where we were, where we are going now this week, and what's to be expected like in the upcoming week. Okay, last week we talked about last week and the week before we talked about ideas of like central angle, the different vocabulary associated with circle geometry. Things like, you know, the longest chord inside of a circle is a diameter, okay, and the central angle is the angle formed by two radii, okay, within the circle. And then there's another concept called the intercepted arc, right, or the arc measure, okay, which happens to be the same or different from the central angle, guys. Is the arc measure of a circle the same or different than the central angle?
Same.
It's the same, okay? So that was something that we had talked about like 2 weeks ago. And then last week, there was a new concept that was introduced. And that was, well, we can actually measure central angles using two different ways. One of which is a degree measure. And that method of measuring angles is what you were brought up thinking and knowing and being familiar with, right? However, that is not the only way that we can measure an angle. And as it turns out, there's a much more natural way of thinking about angle measures, and that way of describing the angle measure is something called a radian measure. Just really quickly, a radian measure, okay, just to recap that idea, okay, a radian measure is actually very, very similar to that of an arc length, okay. And when I say it's really similar to the, it's the same. It's really the same as the arc length, but it's the arc length of which circle there, guys. So again, a radian measure, okay, is a way for us to measure an angle, but for what kind of a circle? The word I'm fishing for starts with the letter U. Does anyone recall from last week? The second letter is N. The first letter is U. The second letter is N.
What does this refer to again?
This is where a radian measure comes from. And I said that the radian measure is actually the arc length of a specific kind of circle. It is the arc length of a blank circle. And the word I'm fishing for starts with the letter U. If you guys don't remember, it's a unit circle, right? It is the arc length of a unit circle. What is meant by a unit circle, guys?
A circle defined by the unit given.
No, radius of 1.
It's a radius of 1. So again, when we describe the angle, right, the central angle, you can do it two ways. You can do it using degrees, or you can do it by using a radian measure. And a radian measure is actually the arc length of a unit circle, okay? And what is a unit circle? It is a circle with radius 1. Again, this concept of describing an angle this way seems very abstract, and I get it. But it is something that we have to be familiar with and get used to, because it is actually the preferred way of thinking about angles when you move on to higher level math, okay? And as your understanding of math grows. Okay, so what I have in front of us right now, okay, in the screen, this is the week in review. And we are going to look at. We're not going to watch these two videos together. Okay, you are going to do that on your own. Okay, you're going to take notes of those two videos. And they're going to be part of one of 3 assignments. We're just going to jump right into the exercises relating to radians and arc length. Okay, but again, and then just to really briefly talk about the assignments for this week, you have one note-taking assignment for these 2 videos, and then you have a second note-taking assignment for this particular one regarding area of a sector. You're going to find out what that is. And then the third note-taking assignment is in regards to inscribed angles and inscribed angle theorem proof. And then there's actually 3 videos associated with the third assignment on note-taking. Okay, so make sure you watch that at your own time. Okay, and submit them according to the assignment that I've posted in Google Classroom. We're just going to jump into Khan Academy now. If you don't have a Khan Academy tab open, please open that up. And we're going to go into radians and arc length. Okay, so I'm going to go over here.
How many taps today?
How many what?
Taps on the next button.
Oh, it's going to be, I think, at least 14. So I'm going to do that along with you guys. So I'm going to hit once.
Something I do to find these
Twice.
videos is just to search them up.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And Chris, the reason why I don't do the search is because I run the risk of, maybe perhaps looking at other things that are titled very, very similarly, right? So what I do is I tap next, however many times, and if you notice, all the assignments, all the videos, they coincide with the pacing calendar here. So what I'm looking at right now, what I'm trying to look for is radians and arc length. So that looks like we need to tap next one more time. So it's going to be 15 times, guys. Okay. So radians and arc length. Right here. Okay. Radians and arc length. So I'm going to tap this, and this is where we are. All right. So I want to give you guys a little bit of notes. So what I'm going to do is I want to jump over to my phone now. And like I said today, I'm acting like a barbarian. I have to write with my fingers because my tablet is still malfunctioning. So I'm going to present over on my phone. Okay. So right now, my phone is presenting, and I am going to, that's my daughter, guys. And I am going to go into the writing app here, which I think I downloaded. Let's see.
You sure have a lot of apps. My phone is similar to that also.
Your phone is similar to this?
Yeah, it's also a Samsung.
It's also a Samsung?
Yeah.
Mine's a Pixel.
Oh, okay.
I also have a
an
Pixel.
old- I have like a grandma SE phone. It's from like 2016. I'm gonna get the new iPhone that comes out in 2 days.
Awesome.
cool.
Is that the
Nice.
iPhone 11?
No, SE.
SE.
I'm a big fan of it because I don't need to carry an iPad mini around in my pocket.
Is it big and cumbersome, Emmett?
Well, the new phone that's coming out,
The
it's like
old
the
one.
size of the old 8. My old one is the size of a 5. I like it.
Oh, okay.
Crap. Where is...
Yeah, I also have a Pixel, but it's a Pixel 3a, and I got that like a few months ago for my birthday, so that was good.
That's cool. I like the Google phone because it takes amazing photos.
Oh, hell yeah.
It's like highly underrated.
Mhm.
because a lot of people are like they're great Apple fans, and they
Oh my
and they
God.
oversee the what Google can do.
And the new 11
Mhm.
does have like 3 cameras attached to it, so it has some focus. Like my iPad can't always focus in, like when I'm taking a picture of a PDF, and the Apple can. I don't know if that has anything to do with picture quality, but
Honestly, I feel like Apple's good, but it's a little too overrated for
All right.
the iPhones. But
My phone, I
Maybe
don't have
because
an
of the
app
history
installed
of
where I
the
normally
iPhone.
write with,
I mean,
and just in a nick of time, my tablet came back online. So I'm going to use my tablet now.
lucky you. Maybe the iPhone's overrated because of its history. I mean, it did pioneer what we all think of phones today. I mean, if you look at Google Pixel, they have similarities to the iPhone. Maybe that's why iPhones are so overrated.
the BlackBerry is the phone of the future.
Yeah, not anymore. They stopped innovating at one point.
Okay, so my tablet's back online. All right, so
Lucky
Here it
you, Mr. Chan. Lucky you.
Wait, why are there
Yeah.
2 of them now?
because one of them is my phone, so I'm gonna stop I'm gonna get out of my phone. I'm gonna close this. Get out of it.
Okay, I'm on.
Hi, morning, Dylan.
You know,
Morning.
Okay. So is there only 2 of me now?
still 3.
There's still 3.
Yeah.
I'm gonna get rid of this.
Maybe you gotta leave the meeting on your phone.
Yeah, I think that's what I have to do. That's why like technology is great when it works, but when it doesn't, this is what happens. There's like a lot of like stall time because you're trying to get stuff to work.
Yes, true enough. I agree.
What was that?
Yes, true enough. I agree.
Yeah.
Now there's only 2 of you.
Now there's only 2 of me. Okay.
Yep.
All right.
I saw you leave.
Okay. So, like I was saying, I was going to give you some notes on the topic for today, and it has to do with arc length, right? So the notes I want to give you is this, okay? And that is, we figured out last week that there was this relationship. Remember that 360 is equal to arc length over the circumference. Remember this? And Michael, you were the one who emailed me about confirming this equation. Remember that?
Yep.
Okay. And then last week, I also went and did something a little further, and I said, well, we can re-express this by saying that it's 2 pi r over here, and then isolate arc length. And if I replace arc length with the letter x, okay, we end up with x is equal to 2 pi r times theta over 360. And then this further reduces to pi times
R
theta
over
times
180.
r over 180, right?
Mm-hmm.
So you guys remember that from last week?
Yeah,
Yeah.
I do
Right.
remember that.
Okay, so now check this out, okay? Theta right now, okay? Theta right now in this formula here is in what units? Is it in degrees or is it in radians?
Radians.
Let's look at this a little closer now, okay? This is the thought process with the derivation, right? So again, we go from here all the way down to this step right now, right? Was theta originally degrees or was it in radians?
Oh, originally in degrees.
It's originally in degrees, okay? So therefore, nothing's changed, right? Theta is still in degrees. Okay? Now, there and And just one other thing I want you to take note of is this thing, okay? Which was something that we had closed the week on. That thing that I'm highlighting in green right now. What is that known as?
Bless you.
Bless you.
Thank you.
You're welcome.
That stuff that's highlighted in green. What is that known as? This is something that we had covered last week. I'll give you a hint. It's a conversion going from
Bless you.
Degrees to radian. Bless you.
Say that again, Emmett.
Degrees to radian.
It's going from degrees to radians. So wait a minute. Theta right now is in degrees, right? If I throw in the angle measure, okay, that is in degrees, okay, so that stuff that's in green will be converted into radians. So another way of thinking about this, okay, another way of thinking about this is I can re-express this in this manner. So instead of writing theta pi over 180 times r, right, I can really then say, oh, it's really, I'm going to call this beta times r, where beta is in. So I need you all to think about this and to be united with me, okay, in the thought process. Do you guys agree with me that the two things that are highlighted right now, they are equivalent?
Yeah.
I just replaced, okay, theta pi over 180 with the Greek symbol beta, okay? So it's like saying I'm telling you that beta represents theta pi over 180. So what would beta here in this case represent?
Theta.
Not quite theta, because theta is in degrees right now. Theta is the
Theta
central
pi over 180.
That's true. But what is another way of calling that? I do agree. It's theta pi over 180.
Radian? Oh.
Yes, that's it. So beta is in radians.
Are radians and radii the same?
No, because a radian measure, okay, is the arc length of a unit circle, and that is what we use to describe an angle measure, okay? So check this out, okay? If that idea is really, really abstract and you're still struggling to digest it, and I totally understand that, okay? This is the main takeaway that I need you to have right now with me, okay? So both of these things, okay, that you see on the screen right now, they both describe what? What did I say X represent one more time? If I scroll all the way to the top, right? What did X represent one more time?
Pi over 360.
What did X represent? So I'm highlighting X and I'm
Arc
highlighting
length. Arc length.
Arc length.
X represents arc length, right? So both of these things represent what now?
Arc length.
Both of these represent arc length, okay? So what I need you to do, okay, you should write this down. This is the arc length formula. This is the arc length formula.
Is it both of those or just one?
Well, it depends on the situation. If you are given an angle in degrees, which formula are you going to use? The first one or the second one?
The first one.
That's right. If you're given an angle that's measured in radians, you're going to then use the second
one.
there. Okay? So these are the two formulas that you need to use, okay, for arc length. And where do these two formulas come from? It stems directly from this whole process, okay, that I just walked through with you guys. Okay? All right. So what I'm going to do now is
B times the radian degrees. Wait.
Say that again
No,
one more time, Emmett.
Wait, no. Would B times radius get you degrees or no?
No. So beta times the radius gives us arc length. And beta right now, is that an angle measure or is it not?
Well, it is.
It is an angle measure. It's an angle measured in what units?
Radians.
Radians. Okay? So again, if you're given something in radians, you're going and you're asked to find arc length, you're going to use that second equation. If you're given something that's in degrees and you're asked to find arc length, you're going to use the first equation. I want to jump back over here. I'm going to stop presenting on this. And I'm going to start presenting, or actually continue presenting on this. Let me see here. Are you guys able to see my screen right now?
Yeah, I can see your screen.
You can see my screen, right? Okay. Let me see. So I'm getting back on this, and the problem that we're looking at right now is this guy right here. Okay. Let me see. So in this case, okay, what are we given, guys?
We're given the radius and the arc length.
You're given the radius and the arc length. Okay, so the radius right now is 2, and the arc length is how much?
5.
5. And you're asked to find out what theta is in radians. Okay, you're asked to find out what theta is in radians. So if you're asked to find out what theta is in radians, okay, which formula are you going to use? Are you going to use the first equation or the second equation, guys?
The second equation.
You're going to use the second equation. I'm going to quickly jump back over here and present with my tablet. So one more time, the situation that we have right now, okay, is we have a circle, okay, with a radius of 2 and an arc length of 5, and you're asked to find out what theta is over here. So theta in this case is, again, the central angle. I want to use the second formula, okay? So the second formula says, well, what am I going to replace x with?
I didn't know you were in chat.
Again, I'm using x is equal to beta times r. What am I going to replace x with?
5.
I want to replace x with 5 because that's the arc length. What am I going to replace beta with? Do I know beta?
Theta.
I want to replace it with theta because that's what they're using here, okay? What am I going to replace r with?
2.
2.
2. So what will theta equal to?
5 over 2.
5 over 2, guys. That's all it is.
That simple?
There's no pi.
Say that again?
There's no pi in there?
There's no pi in this. There's no pi in that. So I want to stop presenting on this. I want to jump over here now. Back to this guy. And what is that? That is
Got it.
2.5.
Are you gonna do the rest?
I always, Mike.
Are we gonna do the rest?
Don't I always?
Wait, what was the answer?
Yeah.
2.5. Okay, so the next one here says, what is the length of arc S shown below? What is the length of arc S? And this time you're given the central angle there is 2, okay? The central angle is 2. Now the 2 there, okay, it's do you guys see this thing I'm pointing out right now? The one that's italicized, right? It says the angle is the angle in the figure is a central angle in radians. Gentlemen, which equation are we going to use? The first equation or the second equation again?
The second equation.
We're going to use the second equation again. That's right. So because we're using the second equation, how do I find out what is the length of that arc? What do I do?
Use the arc length and use the formula. So
Right. So are we finding x? Are we finding beta? Or are we finding r? Or what are we finding here?
We're finding S.
We're finding
Yeah.
x.
Yeah.
What do we do?
Well-
You substitute beta for 2 and then R for 7.
Good. Kian, what is that?
Sorry, what was the question?
Sure. How do we solve this? How do we find s? Emmett just described what we substitute in, but can you actually figure out what that is for us?
Would that be finding?
We're finding out what x.
Would that be finding
is.
degrees?
No, we're not finding the degrees. We're
Hmm.
finding out what the arc length is, and the arc length is equal to the central angle, which is beta, times the radius, which is 7.
7.
Which is, so how do we find the arc length? What do we do?
I think I might need some help here.
Okay, Michael, do you know what we have to do?
I don't think he's there.
He's not there. Who else is there? Let me see. I know Emmett knows. Chris, do you know what we have to do? Chris, are you there?
Yeah, I'm here.
Okay. Do you know what we have to do to find out what the arc length is?
Wait.
It's basically S equals 7/2.
No, it's not
Wait,
7
7
over
times-
2. It's
7 times
7 times 2.
Yeah,
because
7
2
times
here is the radian measure. 2 here is beta. 2 is the central angle. 2 is the central angle in
Oh yeah,
radian.
this time it's stacks that we're solving for, so we don't need to worry about dividing anything.
So
Right.
according to the equation that you gave us before, it's pi times theta divided by 180. Multiply that by the radius.
Yep.
So
and that
means that the
is
radius
arc
is 7.
length. Well, wait a
and-
minute, Kian. That is the formula if the central angle is in what units?
Isn't theta?
Degrees.
No.
In
Degrees. Right now, what is the unit of the central angle here?
The unit is
Radian.
Radian.
Radians. So what's the formula that we're going to use, Kian?
it's beta multiplying that by r. So that's
Good.
basically 7 times 2.
That's all it is. Look how easy that was. Okay, let's take a look at the next one here, guys. All right.
Wait,
so
sorry, I didn't catch that. What was the end result? Sorry.
14.
It's 14.
Oh, okay, so it does stay 4. Okay.
Write a formula for r in terms of theta based on the image below. We need to now find out what is the radius, okay? The angle in the figure is a central angle, again, in radians, okay? So the only thing is, oh, it says here, write a formula for r in terms of theta. So wait a minute. We're asked to find out what are we trying to write again? Are we trying to write a formula for r, or are we trying to write a formula for theta?
We're trying to find
R,
out
so
r.
For r, right? So r equal to something in terms of theta. What would that be?
R equals 4/pi.
4 over, not pi. Again, you see
No,
these.
sorry, theta.
Yeah. So guys, you see we're using the symbol here, theta, right?
Mm-hmm.
Theta is in what units right now?
Radians.
It's in radians.
In radians. Okay, so one more time. Are we using the first formula or the second formula?
Second formula.
You're using the second formula. That's right. We're replacing that beta symbol with the symbol that they're using here, which is theta, okay? And we're replacing x with 4, and we're solving for r. So that means this is going to be, what's the final answer? Michael, do you know?
4 over pi.
4 over not pi.
I mean, oops, 4 over radian.
4 over
Theta.
4 over
Theta.
theta.
Why did I make the same mistake that Emmett did?
No problem. So it's 4 over theta.
All right, let me write that down. 4 over theta, right?
Yep. And we're in the home stretch here. We're almost there. We have 4 more to go. So again here,
About halfway done.
an arc subtends a central angle measuring 3 pi over 5 radians. What fraction of the circumference is this arc? What fraction of the circumference is this arc? Okay, so what is the so I'm going to quickly just draw this on my tablet here, and I'm going to do a quick share screen. Give me a second. Give me a second. So this is 3 pi over 5. This is r. Okay. So I'm going to get back over here. All right, guys. So you're asked to find out what fraction of that highlighted arc length is of the entire circumference. So boys, what is the circumference of the circle in terms of r?
Pi r
Circumference is
squared.
what? Not pi r squared.
Wait, oh no. 2r squared. 2r pi.
Not 2 pi r.
Oh,
That's the
wait.
circumference. What is the arc length here? Again, I'm going to call this x. What is the arc length in this case in terms of r? It's, again,
Well, it's
the
in
central angle in radians
just
times
beta
the
r
radius,
again.
right? So what is the central angle here in this case? What
3
is
pi over 5.
It's 3 pi over 5. 3 pi over 5 is the central angle. That's beta, right? And what are we going to multiply this by?
2 pi r.
No. What was that formula again I gave you?
Beta r.
Beta times r.
Yep.
So 3 pi over 5 is our what? Is it beta or is it r?
It's our beta.
It's beta. So I want to do 3 pi over 5 times what?
Times r.
Times r. Hold on. My tablet is not refreshing. I'm just going to do this again. Okay. So we have this times r. So this is so x is the highlighted length there, but the question is not asking for us to find out what x is. That the question is asking for us to figure out what fraction of the circumference is that length that's highlighted. So wait a minute. This is what they're asking us to find. What is the fraction of the highlighted length? What is x over c, right? So if I do this, if I take this quantity, 3 pi over 5 times r, that's the arc length, is it not?
Yeah.
Divide that by 2 pi r. We need to do a little bit of simplifying here, right? If you see the same things both in the numerator and denominator, what do?
Cancel them out.
You can cancel them out. So immediately I notice here that I have r here that can cancel.
And
I
the
also notice I have a pi here that I can cancel, right? So what am I going to be left with?
3 over 5 over 2.
3/5 divided by 2. How do I simplify this fraction? This is the same thing as 3/5 times how much?
1/2.
Times 1/2.
So it's 3/10.
So it's 3/10. And guys, this is what the question was asking for. It's asking for what is the fraction, right, of that highlighted, of that arc length with respect to the circumference. So now what I'm going to do is I'm going to jump back over here to my laptop. And I'm going to go over here now. And we found the answer to be 3/10. All right.
What's the answer?
3/10.
Okay.
What is the measure of theta in radians? We're sort of really hitting on a dead horse here. So what are we doing to find out what the angle is for theta in radians? What do we do, guys?
We just divide the arc length by 4.
We divide the arc length by 4.
It's just 1.5.
That's all it is. Look at that. Okay. 6 divided by 4. Okay. Michael, how much is that?
1.5.
There you go.
Don't you have to multiply 3 by 8 to get the arc length?
We certainly do. Kian, what is that?
It's 24.
It is 24.
Oh boy.
Amazing. Okay, and then last question, guys. Write a formula for R in terms of theta based on the image below. So that's 7 pi there. What does that mean, 7 pi?
Wait, what was the answer for number 6?
24.
24.
24.
Do you know how to get that, Michael?
Yeah, it was like multiplied the 8 times the 3. Yeah.
Right. Do you know why it's 8 times 3?
Because you are essentially finding the whole circumference of
What is
the arc.
meant by what is 3 in that problem there? Is that the central angle or is that the radius?
Central angle?
That is the central angle. And is that central angle in radians or is it in degrees?
Radians?
It's in radians. So you do 3 times 8 because it's central angle times the radius. So that's why it's 24.
Got it.
Okay, so now we're on this last problem. The 7 pi, is that arc length? Is that the central angle or is that the radius?
7 pi is the arc length.
7 pi is the arc length. Kian, you're on a roll here. If 7 pi is the arc length and you're asked to find out a formula for R, what are you going to do? Can you maybe help us figure that out?
Do you have to divide 7 pi by theta?
That's exactly what you're supposed to do. Okay, so one more time. Theta times the radius will give us the arc length. We are going to isolate R in this case. So yes, it is 7 pi over theta. So I want to go over here. 7 pi
That sure was fast.
by theta.
Yeah.
That was like an echo. Did you guys hear that?
Yeah.
Well, everybody did it at once.
Yeah.
Did you hear an echo for me?
I did. That's because
Like,
all
we
of us
did it at the
hit
same
enter
time.
like a split second after one another.
So that's why.
Okay, so do you guys have any questions for me?
So
No, not
there
really.
are 4 well, no, there are 3 exercises, but there's a quiz. So are we gonna do one exercise on Thursday? Because we normally do all the exercises from Monday to Wednesday, and then from there we just look at the enrichment problems on Thursday.
Kian, don't you worry. We're going to go through every one of these exercises
Okay.
during the week. Okay.
All right.
The only thing is one small catch. The quiz, right? It's different for each one of you guys. So, I mean, I'll try my best to go over the material, but I would encourage you. You know, if I don't get to you, take screenshots of the questions and bring them up during office hours. Okay.
Okay.
Just one last thing before I let you all go. Okay, just really important, and that is this thing right here. So just to recap today, right? These are the 2 formulas, okay, that we've worked on over and over and over and over and over again. Actually, in this particular assignment, which of these 2 formulas did we hit on again and again and again?
The
We hit
radian
on
formula.
Theta R.
Yeah, it's the second one here, okay? Which is again the reason why, okay, for much of like more advanced stuff that you do later on, okay, we're going to move away from this concept of a degree measure, okay, and talk more about angles in the form of a radian measure, okay? So just keep that in mind, okay, as you progress. So for the remainder of today, I encourage you guys to watch the videos that I've prescribed and take notes on it and submit that into Google Classroom, okay? So I want to stop recording now.